Year 13 short revision video number 9. So we're given a graph which is of the function y equals k minus x, all in brackets, multiplied by ln of x, and k is a constant that is positive. Find in terms of k the area of the finite region between the curve and the x-axis. So that's obviously this region here. Now, if we're going to find out the area, we'll need to integrate, and we'll need to integrate between limits. So that means we're going to need to know what these two values are over here. So for reference, I'll call those points P and Q, where the curve intersects the x-axis. Now, we know at those 2 points where the curve crosses the x-axis, the y-coordinate is equal to 0. So this then tells us that k minus x, ln of x, must be equal to 0. And we have a product here. So either this part must equal 0 or this part must equal 0. Now, if k minus x is equal to 0, that very simply gives us x equals k. And if ln of x equals 0, then x is obviously equal to 1. So either p or q must be k or 1. Now, we are told that k is greater than 1. So that then shows that this value must be k and this value must be 1 because k is greater than 1. So we now have our roots. We then need to perform the integral. So the area is going to be the integral between limits of 1 and k of k minus x ln x dx. Now, we've looked at integrals like this in the past. We need to use integration by parts. There isn't an easy substitution here that we can use. The integral is going to take place by parts. Integrals of the format x ln x can easily be done by parts. So what do we need to do? We need to recognise that there is a product here, and we need to set up the integration by parts. So u is going to equal ln x, because that's the part that can be differentiated. Du by dx is equal to 1 over x. And dv by dx, the part that's going to be integrated, is going to be equal to k minus x. V is then kx minus a half x squared. So remember the integration by parts formula. uv minus the integral of v multiplied by du by dx, all integrated with respect to x. So first of all, u multiplied by v, that's the product of these two parts here. So that is kx minus a half x squared multiplied by ln x. I'm not going to worry about the limits for the moment, we'll come back to those in a second, minus the integral of v multiplied by du by dx, so that's the product of v and du by dx. So that's clearly 1 over x multiplied by kx minus a half x squared with respect to x. So again, we'll put the limits in a moment. We'll just set up our integral. So we're going to multiply the contents of this bracket by 1 over x to simplify, so it then becomes k minus a half x with respect to x, and we now need to actually carry out the integration of this second part. So I'm simply writing in the first part as previously. Now the second part, let's integrate it carefully. K is going to integrate to kx. A half x would obviously integrate to a quarter of x squared, but because we have a minus minus here, that's going to become plus a quarter of x squared. And I'm now going to put in the large square brackets with the limits of 1 and k. So we've now got to substitute in these limits and see what we get. So substituting in x equals k first of all, I'm going to get k squared minus a half k squared, all multiplied by ln k, minus k squared plus a quarter of k squared. Now, we want to subtract from that what we get when we substitute in x equals 1. And interestingly, when we substitute that in, we get ln 1 for this part, which is obviously 0, and we're then left with minus k plus a quarter at the end of this. Final stage of the simplification, and you can see we will end up with a half of k squared ln k minus 3/4 of k squared plus k minus a quarter. And this 4-term expression is the area of the curve in terms of k.